Okay. Can I get everyone's attention, please? Yeah, I like the enthusiasm. Woo! Yay! Okay. So I hope you all enjoyed the contest and that I see a lot of nice colored balloons. So that means that you solve problems, which is really nice. We're now moving on to the jury solutions and the award ceremony. And for that, I ask someone from the jury forward. It's all, yeah, you can all come forward. Woo!
Kan ik deze gebruiken?
Zou ik hem? Ja, ik kan hem ook door.
Ja, oké. Okay, the moment you've all been waiting for, the solutions to the problems you've all been working on. So we'll go from the easiest problem to the hardest problem according to you guys. So that's according to the number of accepted solutions before the freeze. And we start with the easiest one, E. So on the top you see a timeline of the accepted and the wrong solutions. So the accepted solution in green and the wrong solution in red. And we also see the solutions after the freeze in blue. Okay, so the question was to normalize the amplitudes to attain a certain perceived loudness. And, well, this was just a kind of rescaling problem. So you would have to calculate the current loudness and then rescale according to that. And there was one exception to this. Namely, if the perceived loudness was already 0, then so if the input was just all zeros, it had to stay that way. Actually, we forgot to put in one test case, namely the -1 +1. So some people checked for the all zero case by checking if the sum of all the solution of all the amplitudes was 0, which isn't actually correct, but it got through our test cases. One pitfall that a lot of teams fell into was that 2 ints, if you multiply them, and these had values of like about 10 to the 6th, would result in an overflow. So out of the 127 submissions, 50 got accepted.
All right, so the next problem was Bellevue, and the problem was asking for what the largest viewing angle was from the horizon to looking straight forward. And the observation here that you want to make, so the quadratic solution was too slow. If you have a point that is blocking the view for some other point Q, then instead of looking from point Q, instead you can look from point P, and that would result in a bigger angle. And if you continue this way, the only points relevant are either from point P to the start, this angle with the horizon, or to the end of the island. And this converts your algorithm in a linear one. And yeah, you just take the biggest angle you find in this way. And alternatively, you could use a convex hull to find only the relevant points, making it n log n, also fine. So still 18 unknowns here. Next problem is F.
Yes, for failing flagship, where the problem was you got 2 wind directions and you needed to compute the angle between them in degrees. So basically you need to convert these strings of letters into some form of decimal number in degrees. And if you start from the back, then the first letter represents some angle modulo 90 degrees. And then for every letter before that, you halve that number. So the next letter represents 45 degrees, the next 22.5, etc. And then you just needed to keep track of which direction each letter would turn the angle in degrees of. And once you got the two numbers of degrees for the two directions, you just calculate the difference between them. And then, of course, make sure that you do this in the right order so that you get a positive number. And there you have your answer. Funny remark, because of the required precision of 10 to the minus 6, you only needed the last 29 characters to actually come up with the correct answer, because all the letters before that would be so insignificant to the final result that actually didn't matter. Just a funny stat. For this problem, there were 144 submissions, of which 39 were accepted before the freeze, and 21 still unknown. Next up, imperfect imperial units. So your colleague has been messing with imperial units and you want to convert them into some more sensical units. Basically, it was just possible for every query to do a quick search, either breadth first or depth first search. Didn't really matter. Just make sure you correct the ratios in the correct order, and then yeah, you get your result for every query, which results in order q times n. You could do slightly faster by pre-caching all the possible conversions. So n was about 100 or so. So then you get an O(n) squared map of one value to another. Just make sure that you map the same unit to itself to 1 and not something, not a number or something, because we saw that go wrong a few times. And then you do a lookup in O1. And then you have O(n) squared plus q as runtime. Then a remark about the precision. The largest values that you could get in the end were 10 to the power plus or minus 303, which only barely fits in the limit of a standard 64-bit double. So no problems there. However, we had some people using C++, and they tried to do count and then fixed and then set precision. The only problem is C++ then prints 0.00000000, etc. for very small numbers. And because the numbers can be as small as 10 to the minus 300, this gives too low relative precision, because your answer is 0, while the answer should actually be something 10 to the minus 300. So that was sad. For this problem, there were 163 submissions before the freeze. In total, sorry, of which 31 were accepted before the freeze. Next up, dividing DNA.
Okay, so for dividing DNA, we have to, we have a set of forbidden intervals that are already present in the database, and we need to partition our string of 0 to n-1 in as many disjoint intervals as possible. And the first observation is that if an interval is forbidden, then all shorter intervals that lie inside of it are also forbidden. And secondly, each interval only needs to be just long enough to be allowed. And these two observations lead to a very simple, greedy algorithm. You just start with the querying the interval 0 to 1, and you just keep growing it by 1 until it is allowed. When it is allowed, you're happy, you add it to a counter, and then you start again with the interval a to a plus 1, and you keep extending that one. So in the end, you only need n queries in total, and not the 2n you got. So here's an example. You could first, this is one of the sample cases, I think. You could first query the character C only, the first one. You got a false answer, then CT, still false, then CTG, which gave you a new correct interval. And then you just start again and continue like that. So only 10 accepted solutions I think the main problem with this problem was that the problem statement was quite hard to parse. Other than that, yeah, the solution is relatively simple.
Well, we continue with the next problem, which is the crashing competition computer. And the goal of this problem was to compute the expected time needed to write characters on a computer which is prone to crash after every character you type. And this sounds like dynamic programming. So the solution is indeed dynamic programming. But it's a little more difficult. Because as an intermediate step, you want to you need the time, you want to compute the time needed to code consecutive characters without saving in between, which helps as an intermediate step for the full problem. And this can be done with some dynamic programming approach. So the time needed to write X consecutive characters is equal to the time needed to write the characters up to that point, plus 1 extra time to type the unit, plus an extra expected time needed to recover from crashing. And that can be seen in the formula below. And, well, using some math that simplifies into a recursive statement, so you can compute all the values at once, or you could just use even more math and compute the values directly with a nice formula. And then when we have this computed, then we can compute the overall answer by using another dynamic programming. And the time needed to code all the numbers between positions 0 and x can be done by either doing everything at once or by saving at some final point k, and in that case it is the dp up till then plus the time needed to code the last x minus k characters all at once. So that results in the final answers, and don't forget to add t at the end because, well, the code still needs to be saved at the end. We saw this go wrong a few times. And overall, this is a complexity of c squared. So there were 56 submissions, of which 10 accepted before the freeze. And then we continue on to the next problem.
Yes, so the next problem is kiosk construction. And in this problem, we have some camping, which consists of a grid of plots, which are all numbered from 1 to some number n. And we want to find the optimal position of some kiosk, which minimizes the distance to every plot according to some kind of algorithm. Okay, and basically what we want to do is for every possible position of the kiosk and every possible plot, we want to compute this distance from the kiosk location to the plot. However, if you just naively do this for every pair, then this will be linear per pair, and this gives a total running time of order n cubed, and this will be too slow. So somehow the trick is to reverse this, and for every plot, we want to know the distance from every possible kiosk location. And this can be done more efficiently by using a BFS or DFS, because somehow the distance to a plot does not depend on where you come from. So here's the algorithm, and here's also a visualization. So suppose, for example, we look at plot number 9 here. Then we know that the distance, of course, if we would put the kiosk on position 9 would be 0, and this 3 and 4, this distance to 9 would be 1. But then if we continue, we see that from 8 or from 7, we would not walk to this position 4 or 3 if we are looking for position 9. So we cannot directly go there, but from position 1 we walk to 3 and we reach the answer. And it turns out at this point, all the other positions, you will always get stuck in some kind of loop if you follow the algorithm. And if you do this with some kind of BFS or DFS or maybe dynamic programming, then the runtime will actually be quadratic in the number of plots instead of cubic. Okay, so there were 31 submissions, of which 8 were accepted before the freeze. So let's continue to the next problem, which is problem H.
Yes, problem H was house numbering. In this problem, there was given a graph. And Every edge represents a street in some city, and the goal is to number all the houses on this street such that no intersection has neighboring houses with the same number. So to solve this problem, we need a few observations. At first, every node can have only at most one edge with the number 1 on it. That's actually a useful observation. Second observation is because the number of nodes is equal to the number of edges in the graph, it means the graph must have exactly one cycle and some outgoing tree branches beside it, such as you can see in the picture. And the third observation is because every node could have at most one edge with the number 1 on it, all the edges in the cycle have to be oriented in the same direction, either clockwise or counterclockwise, because otherwise you would have 2 1s in some node. And finally, the final observation is that all the other edges are then also have a predetermined direction, because all the ones need to face outward from the cycle. So that results in a solution. You first find the cycle, then you try to orienting the cycle clockwise and propagate all the house numbers along the tree branches to give a direction to every edge. And then either it's valid and it works, so you have a solution, or it is not valid because, well, there is some equal high house numbers at some node somewhere. And in that case, you orient the circle of the cycle in the other direction and you try again. And after you've tried both, then you know whether there is a solution or there is not. So overall for this problem, there were 5 accepted submissions out of 31 before the freeze. And the next problem is J.
All right, so now we have an interactive problem. So we have a picture with 10,000 columns or 10,000 integers, and we want to know the value of each integer or the height of each column. And to determine these, we can do these queries asking if integer hi is at less than y. And so our first idea here is to just do a binary search. Well, our first idea might be to do just a brute force, just try all the points, but it's way too much. So we can do a binary search for each column. You get n log n complexity. But it turns out that this is actually way too large, because then we only have 1,200 queries, so we only have really 1 query per column almost. And a binary search is definitely more than 1. So you could try to do some optimization, like only binary search above the current position, but it's still going to be too much. Since most columns need to be handled in exactly 1 query. So really most of the columns need to be discarded in 1 query. And the way to do that is just to check if the column is not better than our current maximum, then discard it. Problem, it could be that the columns are increasing in height, and then each time it's going to be better, and then we need to do a binary search to determine how much better. But then again, we have this problem that we do too much binary searching. So now comes the trick of the problem. We randomize the order of the columns. I see this brings excitement. So now you only need to do... Thank you. So now you only need to do a natural logarithm of w, so ln w number of increments. So if you sort these numbers randomly, and the number of increments is going to be roughly the logarithm. One way to roughly see this is that the first integer that you see is going to be roughly half the maximum height, and then the second integer, if it's larger, it's going to be roughly in the middle one of the remaining step integers, and so you only need like a logarithmic number of increments to get to the maximum. And now the number of queries is n, once for each column, and then for each increment of which there are natural log w, we do a binary search, which is the 2 log of n. This comes out at around 10,000, somewhere around 11,000, sometimes just above, sometimes just below. So there were a lot of submissions here, but only very few accepted actually. So this is a trick. If the input is not adversarial, randomization works great. Lowest latency. Okay, so the next problem is lowest latency. And in this problem we are given 10 to the power 5 random points within some large cube. And we want to find the 2 points which are closest to each other, or we want to find actually the distance between them. So maybe at first you think, well, we can of course try all pairs of points, but this is too slow. And there are also some algorithms which always work for this, but they're quite complicated. But we can use the fact that these points are random to get a more efficient algorithm. So because these points are randomly distributed to this whole cube, it actually turns out that the minimal distance between any of these 2 points is quite small. And actually it turns out that almost always it's smaller than 10 to the power 6. So this gives us the first possible solution, which is a local brute force. So what we can do is we can just take this whole box and divide it into smaller boxes of say 100 times 100 smaller boxes. And then within each box, we can just compare all the pairs of points. Now, there's a slight problem with this because, of course, the optimal pair of points could be just in 2 different boxes. So we also need to perform some checks on adjacent boxes to make sure that we actually get the optimal solution. And if we would compute the expected running time of this, then somehow it works to be approximately n squared over k, where k is the number of boxes. So in this case, k would be 10 to the power 6. And this is fast enough. And there's also something you can note here is that due to the birthday paradox, it will actually be almost always the case that there are 2 points which are in the same box somewhere. And this is also an argument by which you can see that actually this minimal distance will be small. Okay, so here's also a visualization to, so here you subdivide the large box into smaller boxes, and then for every point you basically want to check it with all the points in the box where it falls into, and also these adjacent boxes to make sure you handle these edge cases. Okay, so there are also some alternative solutions. One solution is the divide and conquer solution, where you can repeatedly subdivide your box into smaller boxes, and then you need to do some merging around the edges of this box. Another solution is to do a sorted brute force, so you can just sort all the points on x-coordinate and only check points which are close to each other in x-coordinate. And it turns out that this also works if you do it correctly. Okay, so there were 63 submissions, of which 10 were accepted, and there were also still some in the freeze. So the next problem is problem A.
Yes, so adjusted average. The question was given a number of samples. You get an average of these samples, which is not really what you want. So you just want to remove a few of these numbers to get close to a target. And sure, if this, yeah, so you take the sum and compare it to this target times L, and you kind of invert it. So the elements you want to remove should be as close to SL, and L loops from 0 to K. So you can also remove nothing. Don't forget this. So if L is at most 2, you can just enumerate all the combinations to remove, and this is n squared. But then for L is 3, it gets a little bit too slow, and here what you can do is iterate over AU from left to right, and then have a list of all the, a set of all the sums of 2 elements before that point, and find the sum that's closest to SL minus AU. Let's see, yes. That's the thing, and then for this set you use like an ordered set, and then find the closest element by a lower bound function in C++, kind of binary search. And that gives n squared log n for ls3, and for ls4 you also loop over v bigger than u. So this loop over u and v is still quadratic, and the total time is still n squared log n. And we got 25 submissions, of which 3 were accepted before the freeze and still 13 unknown. And now it's the last problem.
All right, so this turned out to be the hardest problem of the set. Actually, it took us a long time as well to come up with a satisfactory solution, but in the end, the solution is actually quite nice, and to me, not that hard anymore. But I mean, it took us a long time as well to see that the intended solution is actually not that hard. Also, only yesterday, 2 days ago, we improved it a lot and made it much nicer. So given some integers, we want to split them into groups of size at most 8, making as few cuts as possible. And the first observation is that we want to make as many groups as possible that sum to a multiple of k. So we can just do some greedy steps first. For every number that is larger than k, we can just subtract k from it as often as needed to get a number between 0 and k. So we just do we replace x by x mod k. And then everything that's already 0, that's fine. We don't need to do anything anymore. We just count it as one group that sums to a multiple of k. So if I start with 2k, that's one group that sums to a multiple of k. Then for all these remaining numbers, we can pair up complementary numbers. So if k is 7, we can make pairs of all the 2s and 5s we have. And if we make as many pairs as possible, then we either are out of 2s or are out of 5s, or maybe both if we're lucky. So then we have at most 4 different values. In the case of k is 8, the maximum one. A 1 or a 7, 2s or 6s, 3 or 5s, and at most 1 4. Because we can also cancel out all the 4s if there's more than one of them. Yeah. So now we do a DP algorithm where our state is the number of integers of each value. So this is k minus 1 integers, and actually of these k minus 1, only at most 4 will be non-zero, and their sum will also be at most 100. So the number of states, worst case, will be 2 times 33 cubed, which is actually not that large. And this DP state maps these counts to the maximum number of the maximum number of groups that sum to a multiple of k that we can make out of these numbers. So in this DP, we need to do like a DP step where we do this recursive approach. One option is to pre-compute all the sets of numbers that have a sum, a multiple of k. And then we try to just subtract all these sets from the numbers we currently have, and then recurse. A simpler one is to just take the largest remainder you have and merge it with any of the others, but actually this becomes a bit tricky, but I think I will skip over this. So a more natural approach is you take the number that has the least amount of occurrences, and we merge this with one of the other numbers, and then recurse on this. So yeah, but actually the simplest one is you just take the sum of these numbers, and if this is currently a multiple of k, then we found a subset that has size a multiple of k, and then we just remove any one of them, and that's all we do. So every step we just remove one of the numbers, and every time we make a multiple of k, we count it as one of these sets. So yeah, implementing this can be super ugly if you do like 4 or 8 deeply nested loops. But I mean, if you just copy-paste code, that's not actually that much of a problem. But a simpler solution is to just use a dictionary in Python or a map of vectors or tuples or arrays. So there were only very few submissions to this before the freeze, and it was only solved once. So that's the last problem, and we have some statistics. So C was used once before the freeze, but it timed out. So I guess people were hungry for speed, but it didn't work. Better use C++ or Java even, I guess, today, or Python. I guess Kotlin wasn't used because of the issues we had with the IDE environment, sadly. Otherwise, Python seems to be quite popular here, which I like. We always try to make sure that all of the problems are solvable in Python, so glad you're using this opportunity. So as usual, some random facts from our side. 700 commits in our repository, for which 434, oh, that should have been 404, guys, in the main contest. 600 secret test cases, a bit less than last year, but we had problem L now with guaranteed 100 test cases, so that makes for a lot. 165 jury submissions, so I guess that works out as just over 10, maybe 12, 13 per problem. Oh, and as always, Maarten, our head of judge, did a lot of time code golfing in Python. So the rules are you write code as much as you can, then you auto-format it using your IDE, and then you count the number of lines. So infinitely long lines are not allowed. And this year we got to 143 lines, which actually sounds like a lot. Yeah, it's like, you can see, it's like 2.5 lines more than last year, which, 25% harder contest. 2 times as hard as the preliminaries this year. Okay, so we want to thank the proofreaders, Jaap, Kevin, Mark, Nikki, and Thomas. I think they're all here in the front somewhere. And then the rest of the jury, of course. Thank you. And then last but not least, if this is your last year participating in BAPC, we would love for you to join our jury. We always have a lot of fun making these problems. It's like, we're all ex-participants, and this is like how we still try to participate. And so today we just updated the numbers from 2022 to 2023. So did you do that? Did you push it? We don't know. Okay. Otherwise, we'll do it soon. But you can just replace this mentally. The deadline is January 22nd, the birthday of one of our ex-jury members. Yeah, please join us. Thanks. Is that the end? Yes.
Yes. Also, on behalf of the organization, thanks a lot for all the work you put in. Yeah, we also want to give you something, but we don't have it yet, so we'll give it later. Woo! Big applause for the jury. Okay, then we move on to other exciting stuff. We'll do the scoreboard and release the freeze. So first of all, for the company teams, this is how the scoreboard looks before the freeze. We see that there are quite some blue fields still there. So it's interesting what it will look like after the freeze, but already 8 problems solved in the first 4 hours. We don't have the nice resolver thing for this scoreboard. So can I get a big tromgeroffel? So I would like to request Ortec 1 to the front if the team is still present here. Ortec 1, are you still here? Woo! Yeah, you can come upstairs. So, Maarten, will you help with the... We have a nice medal for you. Oh, ja.
Ik geef ze wel jou.
Dankjewel.
Yes. And I think it's now picture time for the pictures. Oh, yes. Well, thank you for participating and well done. Also, thanks for participating for all the other companies. We hope you are also excited to participate next year again. I think the organization of next year is also open to that, so that's nice. Yes, now we need a few minutes to make sure the resolver works. So, in the meantime, Maarten, do you have a nice fact to still tell to all the contestants?
Michael. We had a lot of balloons. That's one point. The ducks, yeah, that's a fun one. I can't share the photo right now. We had a whole bunch of ducks in the jury room, my private collection. We got a clarification request during the test session that asked, hey, are you guys lonely over there? And we replied with no, because we have a bunch of ducks. And they asked if they could have one, but yeah, we're there in the jury room, so they hear all the problems. If we would give you one of the ducks, they could tell you the answer. So,
but I think there also was one team who had a rubber ducky as like
we've seen a couple of rubber
ducks.
I've
seen some, yeah.
Yeah, because of course we need to check all the things that come in during the registration. We check your TCR, we check your keyboards. And of course, we also have to fouilleren. What's it in English? We have to check all the mascots. We need to squish all the plushies to see if there's no hidden electronics inside or something. And we've also seen some Roboducks, so that's nice.
Yes. So maybe before we start the contest, we can already explain what we're gonna do. So we'll see the scoreboard, but some of the submissions are still pending because it was before the freeze of the scoreboard. So what I want you all to do with me, if we see a pending submissions, we're gonna do and then there's two options. Either it turns green and it goes up, so then we're like,
yay!
You can be more enthusiastic, guys. I want all your arms up. So, yes, that makes me happy. Or maybe it's incorrect. Then it will turn red. So we also need to practice what we're gonna do then. But then we're gonna do So. Yes. I think you all know how this works. And if some of our volunteers also want to come up here on the stage to do this with us, you're welcome to also take part. Volunteers. Do you still want to contribute? Okay.
We need more chairs on the podium.
So still a few seconds before the resolver works. More volunteers means more enthusiasm. Woo!
Geef jij straks gewoon medailles aan en dan kun jij ze even uitdelen?
Ja, is goed. Kunnen we ook een foto met nog de jury, zeg maar, met ons twee erbij, of niet?
Een coach komt er meestal ook bij staan. Ja.
Maar wij ook nog, of niet?
Vind ik best.
En dat ze het ook kunnen zien.
Heb ik deze nog nodig?
Volgens mij staat hij automatisch aan.
Technical difficulty.
Vraag, waarom staan we niet aan? Waarom staan we niet aan?
Hij staat op het display midden. Hij heeft geen signaal. Nee, nou, ik vraag of jij dat hebt, maar hij heeft geen signaal. Hè? Hij heeft geen signaal midden.
Ja. Nu staat hij en dan loopt hij weg.
Wauw. Altijd leuk als het dan net werkt. Ja, nu krijg je begint het signaal in te krijgen.
Amigo.
So there are still 327 pending submissions, so that's a lot. A lot of asks it's gonna be. Wow. Oh. Yeah.
Ja, hij gaat onder.
So we're gonna start all the way at the bottom.
Ik kan daar kijken.
Oh, great. Yes. We start with Team Boer Boelie in beweging. En Team Essie Xon. Noob coders. Oh, ah, oh, ah. Ja, maar to the max. Hey. Woo. Fast not last. Pogo snort. Plop. Double trouble. Hey. And then black box. Contra spam spiro. Team Blam. No pending. Coffee beans. Hey. Well done. Double the trouble. Hey. While true height minus minus. 1B 10101. Hey. 3 guys, 1 sack fault. Feather at all. Your local brew moment dealers. So. Yes. Brew moment. Oh, woo! Yes. Congrats to your local brew moment dealers, the winners of the group University of Luxembourg. Woo! Then we move on to SOP. Hey. Double the trouble. Oh, the winners of Group University. Woo! Well done. The coffee beans. 1B 10110. And then 0 is 0. Hey. Sta ik in de weg? Ja. Sop. Plopkoek. Hey. De poolparty. Hey. Sok Polytech Mons. Rookie mistake. Hey. Runtime error. Terror. Hey. Forgotten. Flag, flag, flag. Hey. And then 0 is 0. Hey. Yes. Woo. Congrats to Plopkoek, the winners of Leiden University. Rookie mistake. Yes, Duck Team. Hey. The pool party. Runtime terror again. Congrats to Runtime Terror. Rodina. Hey. Flag, flag, flag again. Hey. Monkey IQ 200 combined. Hippie Pura. Hey. Crystal Moth 3.0. Hey. Caddy flag. MC. Hey. CPU Mons. Hey. Piece of cake. Hey. Duck Team. Hey. Rodina. And flag, flag, flag. Hey! Crystal Moth. At 5 problems still. Yes. Woo! The winners of... Congratulations, Hipipura. PPAP. Hey! CPU Mons. 5 problems solved. Well done. Woo! Then MC. Drive 2011. Hey! Placeholder. Piece of cake. Hey! Balloon Addicts Passionate Coders. Hey! Duck Team. Hey! Flag, flag, flag. With 6 problem solves. Woo! So, the winners from UvA, but also the first to solve problem I. Well done. Woo! Hey! Yeah. WA and chill. Hey! Balloon Addicts Passionate Coders. Hey! Piece of cake again. Hey! String name is get team name. Hey! Expansional Fenwick. Hey! Reduce all the things. But it means you're the first to solve problem D, this team. So, nice, well done. In 97 minutes. Congratulations. With a lovely picture. Aww. We're moving to the top 12. It's exciting. All those good submissions. Well done, guys. Balloon Addicts Passionate Coders. Congratulations. You can come forward. Where are you, Balloon Addicts? You can come forward because you're one of the bronze medalists. And we also have nice medals for you. And not only bronze medalists, also the winners from the University of Groningen and the first to solve problem E. So congratulations. It's the wrong way. Do you also have a coach? Your coach can also come forward if you want. Is there a coach? Do you have a coach? Yes, you have a coach. Yes. Yeah. And then we'll make a nice picture. You can smile to the camera. Yes, okay. Congratulations. We will move to the next on the scoreboards. So, piece of cake. Ooh. Hey! You can come forward. And your coach can also come forward. Yes, you can also come forward. Yes. Oh, gefeliciteerd. Lekker gedaan.
Iets meer zo te staan.
Oh, oké. Gefeliciteerd. Ik heb die andere. Gefeliciteerd. Goed gecoacht. Gefeliciteerd. Yes, congratulations, well done. We'll move on. To exponential Fenwick. Hey. Chindia Targo Visto. Hey. Ada Refactor. Hey. And the duck team with 8 problems solved. And as bronze medalists, you can come forward.
Nog even wat Ja.
Oh ja, oh, dankjewel.
Ik ben even bij het kijken, echt zijn. Allebei.
Gefeliciteerd. Congrats. Congratulations.
Thank you.
Then a nice picture.
Oh.
Yes. And they were also the winners from Eindhoven University. Woo! Then PPAP, we also with 8 problems solved, a bit faster. You can also come forward as bronze medalists. Je mag ook helpen met het omhangen. Het gaat misschien wat sneller.
Ja, 3 deze je hand.
Oh, ja.
Ik weet niet.
Sam, wil je helpen met ze ophangen? Congratulations. Yes. Congrats.
You have a coach?
Is there a coach for team PPAP? Yeah. Congratulations. Congratulations. Yes. Well done. WA and chill. Hey. Hey. Reckless raccoons. But you can still come forward, Reckless Raccoons. Because you're the winner from Radboud. I already see the coach, but here's the other the contestants. Yes, congratulations. Congratulations. Yes. Congratulations. Yes.
Sorry?
Congratulations. Okay. Nice picture. Another one. Yes. Yes, congratulations. And then I think we move on to the silver medalist from now onwards. But still a big applause for Exponential Fenwick. They have a silver medal and they're the first to solve problem K. Woo! First coach, congratulations. Yes, congratulations. 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 And a nice picture. Yes. Ada Refactor for still submission. It's Giron. W1 chill. They chill too much? Is that what you're saying, Samuel? Anyway, you're welcome to come forward as silver medalist. Yeah. Congratulations. 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 I put it the wrong way. Oh, gefeliciteerd met alle ballonnen. Ja.
Yes.
Okay, yes, woo! Then, string name is get team name. And then, China Target Vista with 9 problems solved. And the first to solve problem A. You can come forward. Yes. Congratulations. Congratulations.
Thank you.
Where are your badges? Congratulations. It's the wrong way. Gefeliciteerd.
Dankjewel.
Ja, nou het goed van de... Thanks guys, congratulations. Now we move on to the gold medalist. Ooh. And Ada Refactor, please come forward. Woo! Congratulations. 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 Another one. Gefeliciteerd. Okay, well done. Then to the third place, it get on. But it get on. You're welcome on stage. And if you have a coach, he's also welcome, or she is also welcome on stage. Is there a coach? Yeah.
Oh, dit kan niet. Nee, dat klopt niet.
So they're both the winners from university and the first to solve problem B. Congratulations. Gefeliciteerd. Jij? Gefeliciteerd. Nee.
De jury heeft gewonnen. Ja, die is voor Ludo. Ja, die moet wel.
Oh, we're not done yet. Oh, we are. Yes. Yes, and also the first to solve problem B. Well done. Then, on to the second place. String name is get team name. Come forward. And a very special mention, both the first to solve problem F and problem J. That's a really nice accomplishment. Congratulations. 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 Gefeliciteerd. Well done. A very well-deserved second place and gold medalist. So then we move on to the final submission. So, I would like to welcome Sekvald Go. Please come forward on stage.
Is there a coach?
You solved all problems, so I think that's really great accomplishment. And you were the first to solve problems C, G, H, and L. So yes, good. Well done. Congratulations. 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 Gefeliciteerd. And because you're the first place, we of course also have for you. Congratulations. And we also have an additional prize. Oh, we can take pictures first, yes. Yes. And this prize is also brought forward to us by ProDrive. They're not here, so I will give the prize to you. Ooh. Where are they? No.
Looks interesting.
It's
speelgoed.
nice electronics and hardware. There's another one in the back, but I will give it afterwards. And of course, we cannot give you away without like this, but also without not another nice prize to give to you. So we have for you a very nice Switch. Woo! Okay. I'm just kidding. I'm kidding. We still need this for our other contest, but we do have Switch for you, but not this Switch. Another type of Switch, a Nintendo Switch. So, yes, congratulations. I think you're well-deserved first place because you solved all problems. So, yes, very nice done. Can we get another big applause for Sekveld Go? Yes. As this is the first place, we have come to the end of the BAPC 2022. Aww. I hope you all enjoyed it very much. And I also want to thank all the jury for working very hard. The coaches for, oh yeah, another applause. Woo! The coaches for making sure that all the contestants came here and coaching their contestants. Woo! But, of course, also all the volunteers that helped us out today. Thank you very much. Woo! And also the rest of the GEHEC committee for also all the preparations and all the tech details. Also with help from Michael. Also thank you. And yes, thank you very much. Yes. As I think we've now thanked everyone and everyone has seen the scoreboard, it's time for you to get dinner. You can get dinner outside. There, there are two types of dinners. We have like American buffets and Italian, so you can choose what you want. And there are still drinks at the bar. So, yes.
Jezus, bedankt. Jezus, bedankt. Jezus.